I hope you all had a great spring break. I know we were pretty much stuck at home, but I hope it was a relaxing time for you. So, from the week before spring break, what I was looking for all of you, and everything is updated online, so you can check and see what I have in, is page 623, in which we translated the sine and the cos and the tan graph. Then we did a worksheet on 10.2, which is the 623 homework translating. So that would also be an assignment I'm looking for. And then the third assignment was section 10.5 day 1, which was writing trig equations. There are, those worksheets all have answer keys in my CMH files, video homework answers. And again, I'm looking for those 3 assignments. If you check on my CMH, your grades, if those aren't in, I need those to be in. I thought what we would do today is review what we did the week before break started, which is how to graph translated functions, sine, cos, and tan, and how to write trig equations. So I'm looking at a worksheet in which we have these problems, and I will post this online then in the notes section. So we're going to, again, this is nothing new, this is what we've been working on. If I look at this equation, 3 cos 4 theta, I have an amp number of 3. If you remember, your amp is the number in front of the trig function. And then the number that's times the angle, which is the b number, that affects period. So the period for the sine and the cos is 2 pi divided by b. This is my a, which is my amp, and that's my b. So the period is 2 pi divided by 4, which is pi over 2. If you remember, you have to get me the critical numbers. Those are the numbers on the x-axis, and there are 5 of them. The first one is 0 unless you shift the graph left and right. So that's the first one. So to get the other 4, I simply take the period and divide by 4, which is pi over 2 times 1/4, which is pi over 8. So this graph does not have a shift left and right, so we're going to start at 0, and this is the critical number we're going to keep adding. So we're going to go 1/8, and then 1/8 plus 1/8 is 2/8, which you could leave it that way. 2/8 reduces to 1/4. 2/8 plus 1/8 is 3/8. 3/8 plus 1/8 is 4/8, which is 1/2. Those are my critical numbers, and I have an amp of 3. I'm graphing the cos. The parent graph for cos, if you remember, looks like this. This is the parent graph for cos. This is the parent graph for sine. So I'm simply going to start up. So we're going to graph the cos graph. We're going to start at an amp of 3. And if my pen will work again, I'm going to start at an amp of 3, then I go to 0, then I go to down the lower amp, and then I go back to 0, and there is my cos graph. If I look at my next example, again, this is my A number. It happens to be -5, which means my graph is going to reverse. It's going to go upside down, just like all our functions have done. When the A is negative, they flip upside down. And this is the same as 1/2 theta. So my b number is 1/2. So the period, which is 2 pi over b, which would be 2 pi divided by 1/2, which would be 2 pi times 2 over 1, which is 4 pi. So to get your critical numbers, you're going to take 4 pi and divide by 4, which would just be pi. So I'd be at 1 pi, then 2 pi, then 3 pi, and then 4 pi, because this one starts at 0. And now I'm going to do a sine graph. And again, if you remember what the sine graph, parent graph looks like, it starts at 0. So I would have a sine graph starting at 0. Then my amp is 5. So I'd go down to -5. Then I'd go to 0. Then I'd go up. And then I'd go to 0. And there's my sine graph with the reverse amp 5. if I look at my tan, here my amp is -5. So again, it's going to be a reversed graph. And my period for the tan is different. The formula for the period of the tan is not 2 pi divided by b, it's pi divided by b. So I have 1 pi divided by 2 pi. Remember, this is your b. The pi's a cancel. Your period is 1/2. So then to get my critical numbers, I take 1/2 and I divide by 4, which is 1/2 times 1/4, which is 1/8. Now we have to remember what the parent graph for tan looks like because it's different than the sine and the cos. If you remember, the tan graph, this is our center line, and you do 2 critical numbers on either side. Those are asymptotes, and you must put the asymptote in your graph. Your 0 in the middle, and in the middle, you went up to was where pi over 4 would be in the parent graph, and the tan of pi over 4 is 1. So you'd go up to 1 and down to 1. And that's your parent graph for tan. So totally different in the sine and the cos. So this time then, my center line is the y-axis, x equals 0. My critical numbers are 1/8. So I'd go 1/8 this way, and then 1/8 plus 1/8 is 2/8, which is a 1/4. And then I'd go 1/8 this way, and another 1/8 is -1/4. Those are your asymptotes, which are part of the graph. You have to put those in there. Your 0 in the middle, amp is 5. So it's a reverse graph, so it's going to go down here. And remember, it's a curve. It's not a line. It goes like that. And that would be your tan graph. So then after we did that, we practiced graphs that were shifted left and right, which is called your phase shift. If you remember, it's A, sine or cos, B, X plus, and you could have H or K, C or D, whatever letters you want. But this is your amp number. This affects period. Remember, for sine and cos, it's 2 pi over B. For tan, it's just pi over B. C is your left-right shift. We call it a phase shift in trig. Remember, whatever you do to the x, you do the opposite. You go, if you add, you go left. You subtract, you go right. And D is added to the sine function, which is my y, which is an up-down shift. So those are all our shifts with the trig graph. So if I look at that, this is my A, so my amp is 4. This is my B, it's a cos graph, so I'm going to go 2 pi divided by B, which would be 2 pi divided by 2, which is just pi. My phase shift, it says subtract pi over 4 from x, so you're going to go right pi over 4, and your vertical shift is up 2. This is your C, and that's your D. If you remember from when we did this, sine and cos, the phase shift is where the graph starts. Okay, that's where you're going to start. And not the tan, but sine and cos. So we're going to shift this graph pi. Well, first of all, I'm going to take my vertical shift up 2. So I'm going to graph on that line up 2. And then I'm going to start at pi over 4, because that's where I'm shifting to. Again, you still have to get your critical numbers. You're going to take your period and divide by 4. So I'm going to add 1/4 on till I get 5 critical numbers. 1/4 plus 1/4 is 2/4, which is a half. 2/4 plus 1/4 is 3/4. 3 plus 4 plus 1/4 is 4/4, which is 1. And I need one more. 1 plus 1/4, or 4/4 plus 1/4 is 5/4. So those are your critical numbers. And now I'm going to graph a cos graph, amp 4. So that means we're going to have to go up 4 this way, and from my new axis, down 4. So a cos graph always starts up at its amp. So I'm starting at pi over 4. So I'm going to go up to the amp. Then at my next critical number, I'm going to go to 0. My next critical number, I'm going down 4. Then I'm going to go to the axis, and then I'm going to go back up 4. And there is that graph, one cycle. If I look at my next example, it's a sine graph. My amp is -3, so this is going to be a reverse graph for sine. My period is 2 pi divided by 1/2, which is 2 pi times 2 over 1, which is 4 pi. My phase shift is pi left, and my vertical shift is down 3. So again, I always draw that new axis in first. So that's where I'm going to be graphing. And in sine and cos, phase shift is always where you start. So I'm going to start left pi. So I'm going to start at -pi. That's where I'm going to start my graph. And then I'm going to take my period, which is 4 pi, and to get my critical numbers, I'm going to go 4 pi divided by 4, which is 1 pi. So now I'm just going to keep adding 1 pi to where I'm going to start so that I can get 5 critical numbers. So -1 pi plus 1 pi is 0. 0 plus 1 pi is 1 pi. 1 pi plus 1 pi is 2 pi. And 2 pi plus 1 pi is 3 pi. So those are your critical numbers. We're doing a reverse sine graph, amp 3. Remember, sine starts on its axis, and then it goes up or down, but it's a reverse graph, so this one is going to go... Sorry about that, I didn't mean to do that. I just wanted to change colors here. So I'm going to start at -pi, and I start on the axis, and it's a reverse graph, so then I'm going to go down 3. Then I'm going to go to the axis, then I'm going to go up 3, and then I'm going to go to the axis. And there is my graph. The last one of the graphing ones is a tan graph. And again, remember, the tan graph is different than sine and cos, okay? Tan graph does not start at 0. The line y equals 0, x equals 0, the y-axis is the center. So here I have an amp of -1, so it's going to be a reverse graph. I have a period. Remember, the formula for the period for the tan is not 2 pi divided by b, it's pi divided by b. And I have a phase shift of pi right. This is no longer where I start. The tan graph, that is the center. Remember, tan graph look like this. This is the center. So this line, when your phase shift, becomes your center, and there is no vertical shift. So my center now is pi right. So this is my center. And I'm still going to get my critical numbers the same way. I'm going to take the period and divide by 4. So it's pi over 2 times 1/4, which is pi over 8. So I'm going to do 2 critical numbers. This is how tan graphs. It has 2 critical numbers on either side of the center. So this is my center. And if I take 1 pi plus 1/8, and you can put on your calculators, it's 1 and 1/8. Put on your calculators and get it's 9/8. And if I take 9/8 plus 1/8, I get 10/8. Put on your calculator, which is 5/4. And then I have to get the 2 critical numbers on the other side. So I'm going to go 1 pi minus 1/8. And you could put on your calculator, 1 minus 1/8. Math frac is 7/8. And then 7/8 minus 1/8 is 6/8, which is 3/4 pi. So I should move my axis over, but I'm just going to leave it. So I'm going to put my asymptotes in then. My asymptotes are here and here. And again, it's not drawn very well to scale, but this was my center. And then I have a reverse amp. So normally it goes up here to its amp, but